Alrighty, guys. So I wanted to do a little video to get you guys started on the thing. So I'm going to do number 1 and number 5 on the board. Now this is about free energy. So our equation is delta G equals delta H minus T times delta S. Gibbs free energy, enthalpy, Kelvin temperature, entropy. So in the first problem, we need to look through each number and find out what we're given. Now, number 1, it makes it really, really clear for you. It kind of unpacks the word problem for you. It tells you our temperature is 298.15. It tells you your delta S, your change in decrease in disorder, your entropy is negative because it said decrease, and we got to keep track of our signs as we do this, is negative 0.1027, negative 0.120, skinny little 7 crammed in the side there. During an exothermic reaction, exothermic means the heat's coming out, which means delta H is also negative, in this case, negative 136.9. So now I need to know what is my delta G, and that's going to tell me whether this reaction will happen or not. So I pop it into my calculator, on clear, clear, clear. What crap? Okay, so get negative 136.9 minus 298 times a negative 0.1207. That gives me a negative 100.9. Delta G is negative, and if you remember from the presentation last week, that means we are spontaneous. And so that's going to be number 1, and we just plugged it in. I'm also going to want to do number 5. I still expect you to submit all 7, but this will kind of give you a bit of an edge, show you what's going on. So in this one, the entropy of a system at 337 K, so they gave us a K, so we have a temperature, 337 Kelvin, increases by 0.0221 kilojoules per mole K. What increased? Well, earlier in the sentence, we were told that is entropy, so that is delta S, and because it said increase, we know it's positive, so 0.0221. The free energy, G, was found to be negative 717.5. So now we are asked to solve for the change in enthalpy. We're actually solving for delta H this time, not delta G, so we have a little bit of algebra to do. How do I get delta H by itself? Well, we need to rearrange to get the delta H by itself. So I'm going to subtract this from both sides. Negative 717.5 minus a negative, because it was already subtracted. So now it's plus 337 times 0.0221 equals delta H. So let's pop that into the calculator, find out what our enthalpy change is. Negative 717.5 plus 337 times 0.0221 gives me a negative 710. Which is pretty darn exothermic. There's a lot of heat coming out of this one. Depending on which one you're doing, you may have to solve for different values. Just figure out what you're given, plug it into the equation, rearrange for your unknown, and solve. You guys should be good to go. And now that that's done, I want to needlessly do this because it's cool. That was weird, but I thought it was pretty cool.